And then 2, 3 years ago, this is how phishing would work, or a malicious website would work. Pretend that that server at the top is actually a malicious system. Malicious in that it's a phishing website stealing authentication. It's distributing client exploits. That's the bad guy server. Now, in the old days, this worked for them. But we eventually caught on, and what we would do would put processes in place where as soon as phishing email would go out, we'd identify the IP address of the phishing server, and then we'd shut that system down. Wham! Well, then the bad guys would have to rebuild a new server, put it out, new phishing emails, things along those lines. Well, that was a lot of work for the bad guys. We were taking money from them because we were shutting these systems down. We were impacting their return on investment. Anytime we impact their return on investment, the bad guys will change so they can start making more money again. Well, around 2006, they changed. And what you see on the slide to the right is how they changed. And this is what happens. Say, for example, in this case, I think we're actually using the word example. Yes, we are. www.example.com. It's a website set up by the bad guys to distribute malicious code. Maybe they have the MPAC toolkit. Maybe they have distributors like iframes, things along those lines. But what happens is this, is the IP address pointing to www.example.com does not point to the malicious web server. It just points to a hacked desktop computer. Perhaps your friends at work, your sister's computer, your mother's computer at home. And what happens is example.com points to that computer. Now, that computer is not actually the web server. It's just the IP address pointing to the web server. Now, when you connect to that computer, it's actually a hacked computer that then takes your HTTP request, forwards it to the back-end server, what we call the mothership. And then the mothership gives the web pages to the proxy, and then the proxy gives it to you. So what ends up happening is the IP address associated with the web server or email server or any type of server is not actually the server, but a proxy associated with it. Now what happens is the bad guys will have 5, 10, 100, 1,000 of these proxy servers. And what happens is the IP address for example.com points to this computer. 5 minutes later, it points to this computer, a different proxy. 5 minutes later, it points to another one. And then 5 minutes later, it points to another one. Now, the back-end mothership that is actually the web server never changes. So the bad guys only need to build one of those. Much simpler. These proxies are nothing more than disposable, hacked bot proxies that they control, and then every 5, 10 minutes is changing. So the problem is now, when you get that phishing email, when you learn of Bank of America pointing to hacked websites that are distributing malicious code, what ends up happening is when you get that IP address and you shut that IP address down, you just simply shut down the proxy. 5 minutes later, there's going to be another one. And 5 minutes later, there's going to be another one. So it's almost like a game of, in the US, what we call whack-a-mole. You know, as soon as one system pops up, one of the proxies pop up and you shut it down, another one pops up. So the problem for us is the bad guys have a very robust structure. We're not actually shutting down the web servers. We're simply shutting down the proxies. And 5 minutes later, there's going to be another proxy. So they do this in 2 ways. First, these systems they break into have special proxy software installed on them. I'll go into more on that in a minute. Then DNS. In other words, the DNS names are always changing. So we have to go and look in the DNS. I think this is very slick. It's amazing. Think about it. The guys, this is great for disaster recovery. Very robust infrastructure. We can't shut them down. All we're doing is shutting the proxies down. It's amazing. In some ways, the enterprise management software that they develop is in some ways simpler, easier, and more robust than sometimes the enterprise management software we use in the legitimate world. So this slide shows you how it looks at the network level. Now let's take a look at the DNS records. For those of you unfamiliar with DNS, what you're looking at is what we would call a DIG record. DIG is a Unix command line tool for finding information on domain names. Now, what you're looking at here is the actual domain names of, I believe this was a pharmaceutical site. In other words, selling fake drugs. So what would happen is if somebody tried to shut this website down, you would just be shutting those proxies I was talking about. Now, in this case, you see it's called divewithsharks.hk. The bad guys, for some reason, tend to like domain names that end in .hk or end in domains .info. They're very cheap. They're very disposable. The registrars tend to work with the criminals. In fact, the criminals may actually own the registrars. So now take a look. If you look at the top, what you're looking at are the IP addresses associated with divewithsharks.hk. Now remember, this is the actual malicious website. The information at the bottom is the name servers. In this case, that information will not change. The name servers are the computers that give information out about the DNS resolution. In this case, you see there's 5 different computers that resolve to this divewithsharks.hk. Now look at those IP addresses on how they resolve. Those aren't on hosting web farms. No, those are simple cable connections. That is because they're simple home computers. If you look at this, the Shaw Cable, based out of Calgary, Canada. Some of the other ones here. These are just nothing but simple service networks, home providers, cable networks. Those are people like your mother, your sister, who've been hacked, and they're acting as proxies. They don't know it. Now, we're going to take a look at the same DNS record for the same computer here in a short period of time. I think in about 30 minutes. Let's compare. Yeah. Look at the top, please. 30 minutes later, you see we do this DNS pull for the same domain name. Highlighted in bold, the IP address has changed for 2 computers. The other 3 are still online, but these 2 have changed. In other words, when you connect, if you try to connect to this website, a couple of the proxies have changed. So if we shut down the old ones, it doesn't matter because 30 minutes later, there's a new one. Now, if we look again in another 30 minutes, you'll notice that they have all changed right here. All the IP addresses are different computers, except this one right here is actually one from up here. It came back. What's interesting is the bad guys tend to have some type of uptime measurement capability, where whichever proxies are up the longest and have the most bandwidth are the ones that are kept fed back into the DNS. So they have some type of keep alive checks going on. But the end result is if you look at the top and then look at the bottom, all the IP addresses associated with the web server are changing because the proxies are changing. So if we, the good guys, saw divewithsharks.hk being evil, and we looked up the IP addresses and we shut down all those IP addresses, even if we were able to do that within an hour, it doesn't matter. Because an hour later, boom, 5 new systems are up. And remember, once again, these are nothing more than the proxies. So this creates a very robust network that's very hard to shut down. Now, for those of you who are familiar with DNS, you're probably thinking, why bother trying to shut down all these proxies? Why not go for the throat and go after the name server? Now, for those of you who aren't familiar with DNS, the name server is the authoritative server that gives out the information to all the other it's the name server is what gives out all the information to all the other DNS servers about the systems. If you can take out the name server, then they can't constantly be changing all the different IP addresses. So the name server is what we want to shut down right here. And in this case, you see it over here. Now, the bad guys know this. They know that if we can control or shut down their name servers, they can't distribute new DNS records, and then the domain name will just stop changing and eventually time out. So the bad guys have created something what we call double flux. What I have just described here is what was called single flux. We saw single flux because only one element of the DNS records are changing. Just in what we call the A records. whenever we go ahead and we translate the domain name to an IP address. Double flex is when not only the A records change, but the name server records change. So they're constantly changing. This means you don't have any way of shutting the system down. What you would have to do is actually go to the registrars. A registrar is nothing more than the organization where you register the domain name. So folks, like if anybody here has ever registered a domain name, such as with Network Solutions, GoDaddy, whatever, those are the registrars. Then what they do is they give you the information. They're the ones that say where your name servers are. Then you go ahead and set up your DNS records in the name servers. Now the problem is if we can't shut down the name servers, we have to go to the registrars. And as I mentioned before, some registrars will work with you and help you shut down domain names, such as divewithsharks.hk. But there's, I believe, 600 to 800 different registrars, on the internet. Some of those are most likely owned by the bad guys or have relationships with the bad guys. So they've created a pretty robust method for protecting themselves. But let's go in again, once again, some examples of what double flex is and what it looks like when the name servers are changing. Now, what I just discussed, what I just gave examples of, is single flex. Look to your left. As I said before, what happens is here, the client, or we should call the victim. What happens is they resolve the domain name, in this case example.com, and then they go to the proxy server. In this case, what do we have here? All right, what happens here is that what we're showing here is the query. It goes to the main registrar, or the root server, points to the name server, boom. This right here is the weak point. If we can shut down the name server in single flex, then we shut down their ability to constantly be changing the IP addresses. What the bad guys do in double flux is the zombies, the proxies, are also the name servers. So the name servers are also changing all the time. If you try to shut down a name server, 30 minutes, an hour and a half later, the name server has changed. So even now, the bad guys are creating a very, very difficult network to shut down. So what you see here on the left for single flex, they go to the rootserver.com. They find out the name server for, in this case, example.com. You go to example.com, and that's the guy that's going ahead and keeps giving you all the different IP addresses. In double flux, what the bad guys have done is it says when you go to the root server for .com and it points you to the name server is nothing more than a bunch of different IP addresses that are proxies that will then go ahead and do DNS proxy, not just web proxy, but DNS proxy back to the mothership. So now we can't even communicate directly with the name servers. We're going through another layer of protection. So what the bad guys have done now is anytime we try to shut anything down, it doesn't matter because it's always changing. Let's take a look at some records. Once again, these are real records from the bad guys, I think taken maybe in February or March. In this case, it's a MySpace attack. What it is it's a domain name that looks a lot like MySpace. What they're dealing is stealing MySpace login accounts. So this is more of a phishing attack than it is a malicious web server attack. Now, if you take a look at the top, it's called login.my, but if you look at it, it's misspelled, mylspace.com. So it's using a domain name that looks very similar to MySpace, but in case it's not. Now, let's go up here. There's the 5 IP addresses. These, remember, are nothing more than proxies. So when you try to connect to this phishing website, you're actually connecting to reverse web proxies. Also, take a look over here, and here are the 5 name servers. And then look at the address records, the A records for the name servers. Once again, now, if you look at these address records, Roadrunner Network, Comcast, SBC Global, Ameritech, these are all predominantly common service provider networks. So these IP addresses are, once again, nothing more than home networks. So not only the web proxies, but the DNS proxies are part of this fast flex network. So let's go ahead and take a look at what happens here. This is 4 minutes later. All right, all we're doing is we're constantly doing DNS queries. 4 minutes later, all 5 IP addresses that are associated associated with the domain name is changing. That's fast.